All right, guys, welcome to your first lesson. Everything that we're going to cover today should be review. You have done this in previous classes. So we are going to start with the Pythagorean Theorem, and then we're going to talk about simplifying radicals in case you don't remember how to do that. Okay, so Pythagorean Theorem is the first thing that we're going to look at. It is named after a guy named Pythagoras, who was a really interesting character. He kind of he was one of the ancient Greeks. It was back in the day when math schools were kind of like cults. So he was an interesting guy, had some pretty strong opinions about beans, and just, had some interesting stuff going on with him. But the big thing that he is known for is kind of solidifying this Pythagorean theorem. He wasn't really the first guy to think of it, but he kind of solidified it and made it popular. So we call it Pythagorean theorem. Okay, so the first thing that you need to know about the Pythagorean theorem is that this only works in right triangles. That is important. You can't do it any other time. It only works when you have a right triangle. Okay, so this is a right triangle. We use that little box in the corner to show it's a right triangle. Okay, the point of the Pythagorean theorem is that you use it to find missing sides. Okay, so you use it to find missing sides of, again, has to be right triangles. Okay, I kind of ran out of room there, so I just wrote a symbol for a triangle instead of the word. Okay, and the equation for it is a squared plus b squared equals c squared. Okay, and the big restriction that you need to keep in mind is that your c value always has to be your hypotenuse. Okay, and the hypotenuse, if you remember, is the longest side of your right triangle, and it is always opposite the right angle. Okay, so when I look at my picture over here, here's my right angle. So the side opposite it, that is your hypotenuse. So this side must be side C. Okay, so that has to be C. It's the longest side and it's opposite the right angle. Okay, the other two sides, this side could be A or B, doesn't matter. This side could be A or B, whichever one the other's not. So it doesn't matter which one is which for these two, but this one has to be C. Okay, so let's take a look at these. Excuse how wobbly they are in this video. My printer, for some reason, didn't print the triangles, so then I had to kind of draw them in by hand. Okay, so we got this triangle here. So the first thing that we need to do is identify which side is which. So this is where my right angle is. That's the side opposite it. This side has to be C. All right, and then these two could be either A or B. It doesn't matter which one's which. I'm going to call this side A, and I'll call this side B. Okay, so then when I plug this into my Pythagorean theorem, it says a squared plus b squared equals c squared. Well, a is 6, so I'm going to have 6 squared plus b, well, b is x, that's my unknown, so x squared, equals c squared, well, c is 10. All right, and then we're just going to simplify this. So 6 squared is 36, x squared is my unknown, 10 squared is 100, and then I'm going to subtract the 36 from both sides to get the x squared by itself. So 100 minus 36 is 64. And then I'll square root both sides to get the x by itself. Technically, it's x equals positive or negative 8, but we can't have a side length of a triangle that's negative 8. That doesn't make sense. So it's just x equals 8. Okay, so this side of this triangle right here is 8 units long. Okay, so not too bad. Let's do this next one. So in this guy, again, here's my right angle. So that side opposite is going to be C. Okay, these two, it does not matter which one I make A and which one I make B. I'm going to call this one A. I'll call this B. Okay, so Pythagorean theorem, a squared plus b squared equals c squared. So 14 squared plus x squared equals 15 squared. A squared plus b squared equals c squared. Okay, 14 squared is 196. Okay, x squared is just unknown, and then 15 squared is 225. If you don't know that across the top of your head, use a calculator, no big deal. I'm going to subtract the 196 from both sides to get the x squared by itself. So that's going to be 29. And then I'm going to square root both sides here. Okay, when I take the square root of 29, it's not a whole number. So I'm just going to leave this for right now as the square root of 29. We're going to talk about simplifying radicals in the moment. That one's already simplified. Okay, so that is the length of my final side. Yes, I would like you to write it as a simplified radical, not as a decimal. Okay, so that's how you use the Pythagorean theorem. So pretty straightforward, not really difficult. You just really have to pay attention to where your right angle is so that you know which side is C. Okay, now these guys, here we get a whole number answer. Here we got a square root that doesn't simplify, but sometimes you are going to need to simplify your radical answer. Okay, so we're going to do a quick just review of how to simplify radicals. I'm going to show you two different ways to do it. I do not care which method you use. I just want you to be able to simplify your radical. Okay, so the first one is called the least square method, or the largest square root method, excuse me. This is by far the faster method if you are really familiar with your multiplication facts. If you are not as familiar with your multiplication facts, this one can take a little bit longer, but it's a little bit easier, okay? So it's just kind of a preference thing. So for the largest square method, you need to know, first of all, what your perfect squares are, okay? So I'm going to start by making a list of my perfect squares. Okay, so those are numbers that when you multiply a number by itself, what the answer is. So like 1 times 1 is 1, so 1 is a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, 25, 36, okay, 49 would be the next one. They keep going. You might not need any more bigger than that, but it's just your perfect squares. Okay. So what you want to do now is you want to look at what this number is, and you want to look at these perfect squares, and you want to figure out which of these perfect squares, what's the biggest one that evenly goes into 72. Okay, so for example, 1 evenly divides into 72, okay, but it's not necessarily the biggest one. So I'm going to go through and say, okay, well, what about 72? Does that divide by 4? Yeah, 72, 4 goes into that 18 times. So that is bigger than 1. So I'm going to keep looking until I find the biggest one. Does 9 go into 72? Yeah, 8 times. 9 is bigger than 4, so we're going in the right direction. Okay, what about the next one? Does 16 work? No, not evenly. Okay, what about 25? Nope, not evenly. What about 36? Yeah, 36 goes in evenly, and it only goes in 2 times. There's not going to be something bigger than 36 that's going to go into 72. Okay, so 36, we figured out, okay, that is the largest one. So it's the largest that evenly divides 72. That's what I'm looking at there. Okay, so what I'm going to do is I'm going to take this square root and I'm going to break it into 2 baby square roots. And I'm going to say that this is the same thing as the square root of 36 times the square root of 2. Because when we divided 72 by 36, we got 2. Okay? From there, the square root of 36, that's a perfect square. The square root of 36 is 6. 6 times itself is 36. And the square root of 2, there's no whole number times itself that equals 2. So I'm just going to leave that as the square root of 2. Okay? And that is your simplified answer. So that method works really well if you're pretty good at recognizing when one of these numbers evenly goes into 72 or whatever another number happens to be. You just have to be careful because, like, we figured out that 9 went into 72. If you had used 9, then you wouldn't have simplified your answer completely, and you'd have to do it again until it was totally simplified. Kind of like simplifying a fraction, right? If you have, like, I don't know, 20 over 30, and you divide it by 2, and you figure out, oh, 20 over 30 divides evenly by 2. Yeah, but then you're going to be able to simplify it more afterwards, okay? Because 10 is actually the biggest number that would go in. Okay, so that's how you do it with that method. That is the fast method. It's definitely faster if you can just kind of in your head think about which one of these goes into 72. But if you're not good at that, that's where your birthday cake method comes in. It's just a little bit faster. So the birthday cake method, instead of looking at your perfect squares, you look at prime numbers. So prime numbers. Prime numbers are numbers that don't divide by anything except 1 and themselves. Okay? So like 2 is prime because the only things that go into 2 are 1 and 2. 3 is prime because it only divides by 1 and 3. 4 is not prime because 2 also divides into 4. 5 is prime. 6 is not prime because 2 and 3 divide into 6. Okay? 7 is prime. 8 is not prime because 2 will divide into it, and it only is allowed to be 1 in itself. 9 is not prime because 3 goes into it. 10 is not prime because 2 goes into it. But 11 is. 12, no. 13, yes. 14, no. 15, no. 16, no. But 17 is prime. And they actually keep going from there. But that's probably the most that you'll need. Okay, so how the birthday cake method works is we are going to divide 72 by any of these prime numbers. It doesn't have to be the biggest, it could be any of them. Okay, so I'm going to come down here. I'm going to start with 72, kind of at the bottom. I'm going to draw a little division symbol, like how you did long division when you were a kid. Okay, and I'm just going to find any of these that evenly goes into 72. 2 does, right? 72 is even, so I know 2 goes into it evenly. So I'm going to put the 2 here. 72 divided by 2 is 36. Okay, and then I'm going to take this 36. I'm going to do the same thing. Any one of these prime numbers that evenly goes into 36. It's even still, so 2. So I'm going to draw another division sign around that. I'm dividing it by 2. 36 divided by 2 is 18. Okay, now I need another prime number that evenly goes into 18. 2 still works, it's even. So I'm going to divide it by 2. That's 9. Okay, now I need a prime number that goes into 9. 2 doesn't work anymore, but 3 will. So I can divide this by 3. 9 divided by 3 is 3. Okay, and then I can divide 3, right? 3 goes into itself once. Okay, and when you get to the top, see how this kind of looks like one of those like fancy birthday cakes with all the different layers? So when you get to the one at the top, that's like the candle on top of your birthday cake. That's how you know you're done. Okay, so that's why we call it the birthday cake method. All right, and then what you're going to look for from here is you're going to look at all of these prime numbers you divided by and find pairs of them. So here's a pair of 2s, and here's a pair of 3s. And then we got one leftover 2 that didn't have a pair, right? So your answer for this is going to be the prime numbers that go on the outside. So the 3 goes on the outside, and the 2 from this pair are going to go from the outside. And this 2 that was left over is going to stay on the inside. Okay, so these 2 numbers here, right, those came from my pairs. And this number here was the leftover. Okay, and then I can just go ahead and multiply anything that's in the same spot. So the 3 and the 2 are both on the outside. I can multiply that to 6. And there's the same answer that I got over here. Okay, so 1, this takes longer, definitely. It does go much faster once you get used to it because you can fly through making this and then writing the answer. But it definitely takes more steps. It's longer than this one, but it's more useful if you're not great at finding multiples of something. Okay, because usually dividing by like 2 and 3 is pretty easy. Okay, so either way works, you can do either. All right, so what you're going to be doing with your Pythagorean theorem is when you get a problem like this, sometimes you're going to have to simplify it. So let's look at this example down here. Okay, using my Pythagorean theorem, here's my right angle, there's my opposite side, so this has got to be C. And then these sides, either one could be A or B. So this one I'll call A, this one I'll call B. So it's a squared plus b squared equals c squared. So 6 squared plus 12 squared equals c squared, so x squared. Okay, notice that this one, the x is in a different place than it was in the other 2 examples. That's fine. All right, so we're going to simplify this. So 6 squared, 36. 12 squared, 144. That's my unknown. When I add 36 and 144, that's 180. Okay, and then I need to square root it. So I'm going to get x equals the square root of 180. Okay, and then I need to simplify that. So 180, I'm either going to find the largest perfect square that evenly goes in, and you can kind of maybe see how, like, off the top of my head, I don't know which one of these, if any, goes into 180. Okay, but I do know that 2 goes into it. So that's where my birthday cake can potentially be kind of useful. Okay, so that's kind of what you're looking for. So simplifying this, using method 1, you would eventually realize that, oh, 36 goes into 180, and it goes in 5 times. So then the square root of 36 is 6, and that simplifies to 6 root 5. Okay, but again, if you can't just look at that and figure that out, that's where this birthday cake is handy. So 180, I know that divides by 2. 2 goes into 18 9 times, so that'll be 90. Right? 2 goes into 90, goes in 45 times. Okay, well, 45, I know 5 goes into that 9 times. Then I know 3 goes into that 3 times, 3 goes into that once. I've got a pair of 3s and a pair of 2s. So on the outside, I'll have a 2 and a 3. And then on the inside, I'm going to have that leftover 5. So 6 root 5. So same answer either way. Doesn't matter which method you use. I'm never going to ask you to use one method or the other. You just need to be able to simplify your radicals. So then my answer here is going to be 6 times the square root of 5. Okay, so that's your Pythagorean theorem. That's how you find a missing side of a right triangle.